let's see. What's your thinking? Because I see you've got 6
1/6 and
there.
then. Oh.
Yeah.
Oh wait, I think I got it now.
Okay.
Wait.
Just 1/6.
Can I do this like that, and then another one?
Sure.
Like that?
Yeah. Yeah. Well, okay. So I think I see. Okay. Yeah, that's 1/6 and that's 1/6. Excellent. What I'm gonna do, because we know these are 1/6, right?
Yeah.
We've established that they're one. Each of them is 1/6 of the hexagon.
Yeah.
So, but good. You took 1/6 and you added another 1/6 to it. Let's see. So, what is 1/6 plus 1/6?
2 12. Wait, what? Yeah, 12. Wait.
This is why I'm doing this. 1/6 and 1/6. If you just had a look at it without even thinking about writing down an answer, what does it look like you have in front of you? Those are sixths, right?
2/6.
2/6, yes. And I'm actually really glad you said 2 12ths because that's a very, very...
Because I always add the top and then sometimes I add the bottom.
Sometimes you add the bottom, right? And it's confusing because when you multiply fractions, you multiply the bottom, you multiply your denominators and you multiply your numerators. But in addition and subtraction, you don't. And you can see, right? And I like that you looked at this, you said 2 12ths and then you said, wait, I know the sizes of those pieces hasn't changed. Those still look like sixths to me. There's just 2 of them, right? So yeah, 1/6, it kind of helps show like why we don't change the denominator?
Yeah.
Yeah, because the piece size doesn't change. The number of pieces changes. You take 1 and you add 1. It's exactly the same as saying, 1 dog plus 1 dog equals 2 dogs.
2 dogs.
Right? Okay, so here's sort of the next level up of the challenge. Is there another way we can say this shape, exactly this shape and this size, in other words, this quantity, with another block or blocks?
A rhombus?
A rhombus, yes, exactly.
Oops.
It's okay. Right. Okay. So what part of the whole is the blue rhombus? What part of the whole hexagon is that again? Remind me.
Wait. Oh, a third.
It's 1/3. Yeah. 1/3 and 2/6. Same thing, right?
Yep.
If I put that on a hexagon, you can tell that's 2 out of 6 equal pieces
Yeah.
that make the whole. And then that's 1 out of 3 equal pieces that makes the whole. 2/6 and 1/3, same thing. So you may ask, why? If it's 2/6 or if it's 1/3, what's the big deal about that? Why can't I just have one way to say it and that's fine? Well, when first of all, you're going to you definitely hear this in 5th grade. In 6th grade, you start talking about fractions. Reduce your fraction, put it in what we call lowest terms. There's all these words I don't like, well, what are we doing? And usually people say, well, it's making the numbers smaller, right? It's making the numerator and the denominator smaller. And it's true that 1 and 3 are smaller numbers than 2 and 6. But what are we really doing? We're calling this amount, this quantity, we're giving it a name in fewer pieces. Why talk about 2/6 when I can just say it as 1/3? And there's times when I need to say it as 2/6. There's times where I really want to say it as 1/3. If I go to the deli and I want 1/3 of a pound of turkey, and I say, give me 2/6 of a pound of turkey, they're probably gonna look at me strange. And if I said, give me 30/90ths of a pound of turkey, they're gonna look at me really strange, right? Like, why am I talking these tiny little, little fractions, 90ths, and give me 30/90ths, Or if I said, we live about, 7/14 of a mile from school. Like, I walked 8/16 of a mile to school today, Maybe people know what that means, maybe they don't, but they know one. It's simpler, yeah, right? 1/2, you know what half a mile is. You don't have to think when I think about 8/16 of a mile. So that's it. It's naming the quantity in fewer pieces. Okay. Good. Let's try another one. I'll put my notes over here. How about these hexagons? How about 1/6? Actually, you know what? I'm gonna let you do this. I'm just gonna write it down. 1/6 plus 1/2. Go ahead, play with. Build 1/6 plus 1/2.
Should I just say the answer?
Yeah, why don't you hold on for a second because we've got somebody coming through here.
You can stop the video and restart.
Okay. All right. Okay, 1/6 plus 1/2. So, what do you want to do about that? How can you say that?
Like the fraction?
Yeah, like what that is altogether. And feel free to use other blocks to move it around.
4/6.
4/6. I like it. Why is it 4/6?
Because I know that 3 triangles make a trapezoid.
Aha.
But there's another one.
Uh-huh.
So.
But there's another one, so it's 4/6, right? Which is an interesting thing here because we start out talking about a piece that's a 1/6 in size, and then we've got another piece that's a different size. But our answer, we said it in terms of 6, right? 4/6. Well, how do I see? I don't see 4/6 here. I see 1/6, and then I see something else. But I like what you did. You took the 1/2, and you gave your 1/2 a new name. What did you name it?
6. 3/6.
3/6. Good. And then suddenly, magically, we have 1/6 plus 3/6, which is 4/6. Yeah. Once we have those denominators the same, once we call them by the same name, we call them by the same size piece, then the math's really easy, right? It's 1 plus 3. Which we know is 4. It's like saying 1 dog plus 3 dogs equals 4 dogs. It's kind of like if you were saying one Rottweiler plus 1 Beagle. Well, you can't say that's 2 Rottweilers or 2 Beagles or 2 Rottabeagles or something. You know, but if you call them all dogs, 1 dog and 3 dogs, 4 dogs, right? That's not a great example, but I'm going to get the idea. You have to give them the same name. What else? Is there anything else you can call 4/6? That amount that you have there. And use your blocks if you want.
You can do 2/3.
Yeah. Can you show me how 2/3 is 4/6?
Because like.
Yeah, with the thirds.
Oh.
Yeah, show me how 2/3 and 4/6 is the same thing.
Oh shoot, I forgot how to put these together.
I always have trouble with those.
Oh, there we
always
go.
To this day.
2/3 and then what was it?
4/6.
Because
Yeah.
I'm a genius.
Oh, you took a sec.
Oh wait, did I do it right?
No, you're doing it fine.
There we go. It's the same.
It's the same.
There we go.
Yep.
Beautiful.
Oh, that is beautiful. And just somebody pointed out that when you put 2 more green triangles there, it looks like the recycling sign.
Yeah, it does.
The recycling insignia. Look at that. 1/6 plus 1/2. 4/6. 2/3. Exactly the same.
That.
Yeah, that's where we started, right?
Yeah.
We took those 2 and then we made, we put them together and we gave them 2 different ways to name it. You know, you named it 2 different ways. And like the 2/3, or the 2, excuse me, like the last problem we did with the 2/6, You took this amount and you set it in fewer pieces. 2 pieces with the same, you know, you found another name that you could call them, 2/3. Nice. All right, let's try. Let's try subtraction. 2 1/3 minus 2/3. Aha! Now we're throwing a mixed number in there. Things get a little crazier. Go ahead and use your blocks. Make that problem. Take your time.
Art. That's right.
Okay. You've got 2 1/3. And you've got to find a way to take away 2/3.
Oh, I have an idea.
Okay, go ahead.
Sorry. So, wait, if I did that, wait. So, take that away.
Mm-hmm.
Then add that.
Nice.
So it's 1.5. Wait, did I do that right?
What I'm going to do, just to clarify, I'm going to take away these 2/3
Yeah.
that you were going to subtract.
Mm-hmm.
You tell me what you did, and let's see, I think one of the thirds just got sort of lost in the shuffle here, but
Yeah.
Oh no, actually it didn't.
I changed the whole into thirds.
Right.
So then I could take away 2/3, but I only took away 1.
Right.
Wait, but there was another one.
There was
So I did
another
do it
one.
right.
You did do it right. Yeah, no, you did.
I'm proud of myself.
You should be proud of yourself. You took that whole.
Mhm.
You said, I'm going to rename it in more pieces. Now here's a time when you want to rename that one whole in more pieces. Maybe you don't go to the deli and order 30/90ths of a pound of turkey, but there are times when you want to call one 3/3. And you called it 3/3 so that you could take away 1/3. All right, so it's 2 1/3 minus 2/3 is, read your answer.
1 and 2/3.
1 and 2/3. Good. 1 and 2/3. 1/3. It's like I have to make sure that's right. All right. Let's do one more subtraction problem. We're doing a fantastic job. We've gotten through a lot of work, not a lot of time. Okay. I should build 2/3. And then think about how you can take away 1/2.
Oh,
Yeah.
wait, I got
Good.
it.
Yep.
Okay, so I just need to do that.
Nice.
And then you have to take away half, so that's half. Then you take that away.
Beautiful.
And then what's that?
So what's your answer?
1/6.
1/6. Excellent. Yeah, and I really like what you did, which is you saw that. You saw that when you laid the 1/2 over the 2/3 that there was 1/6 left, but you did the extra. What I think is sort of the extra step of you not only renamed but you rebuilt the one